go. So we're on 1-4B. Notes. Finding equations of inverses. So in the beginning of the year, we talked about the different representation of functions, right? We had mappings, tables, ordered pairs, graphs, and equations. So you knew they had to come from somewhere, right? So we already did the 4 easy ones. Now we're on to the other one, okay? So to find the equation of the inverse, what we're gonna do is, just like you did with the other ones, we're switching our X and our Y, okay? However, after we switch our X and Y, we're then gonna solve for Y again, okay? So we then solve for Y again using inverse of operations. So that means that we're using, pin just stopped working. Oh, there it is. PEMDAS, but we're using PEMDAS backwards because you're solving, not evaluating. So SADMEP, we're gonna SADMEP it, is what I like to call it, okay? And then you're gonna write your final equation in inverse notation. So whether it's Y or F, you're gonna write it in inverse notation, okay? All right. So for example, we have Y equals 4X plus 8. So step 1 says for us to switch the place of X and Y. So this becomes X equals 4Y plus 8. Step 1, switch X and Y. Is that what we just did? Okay, step 2 is to solve for Y. What steps will I take to solve for Y? And SADMEP. Is there anything I can subtract or add first? I can subtract 8. What I do to one side, I do to the other. These are not like terms, so they just become neighbors. So it becomes X minus 8 equals 4Y. Okay, I still need to get Y by itself. So now what do I do? And when you're dividing and multiplying, that applies to each term. So I divide X by 4 and I divide 8 by 4. Now is my Y by itself? Y, yes, it is. So step 3 is to write it in inverse notation. So Y is by itself, so it becomes inverse Y equals, and you're going to simplify. So we're simplifying here. Can X divided by 4 be simplified? No. Minus 8 divided by 4, can that be simplified? To 2. So this is my inverse function. If you can solve for Y, it shouldn't take you a minute. It's the exact same steps of solving for Y. The only thing that is different is you're adding a -1. That is it. That's the only difference from algebra 1 is you're solving for Y, and at the end you add a -1. That is all that's different. If you're choosing to make it more than that, then you turn it into f of X into a Y and proceed. All right, so here we go. An example, what if I don't have a Y? It says f of X. Oh my gosh, what am I gonna do? You change f of X to Y, okay? Just for the sake of switching X and Y. So now I'm gonna switch X and Y, and that becomes X equals 7 minus 5Y. That's step 1. Step 2 is to get Y by itself. What do I need to do to get Y by itself? I have a +7, so I'm going to cancel out a +7. I'm going to subtract 7. And what I do to one side, I do to the other. These are not like terms, so they become neighbors. That's step 2, get the Y by itself. So now I need to get Y by itself. Is it by itself yet? Absolutely not. So what's my next step? Divide by -5. Now is Y by itself? Yes. So this is where the F comes back into play. So I started off with an F, so I have to end with an F. So the inverse F, inverse function equals, and when you are subtracting two fractions with the same denominator, they can be combined over one denominator. Does that sound familiar? Okay. Okay. If I'm subtracting two fractions with the same denominator, they can become one denominator. Does that make sense? Okay. Now, this is where it gets tricky. This is a correct answer. This is correct. However, it is not proper. There is a difference. Okay. This is correct, but it's not proper. And the reason why it's not proper is because of this guy right here. When you're writing a proper equation in mathematics, if you do not have to lead with a negative, you do not lead with a negative. Okay. So in order to remedy that, you literally are going to change and rearrange. So you're going to change the signs and rearrange. So you change everyone's sign and you rearrange so that your leading term is not a negative. Okay. So by changing the sign, so this becomes negative, this becomes positive, and this becomes positive. So I changed the signs. Now I'm going to rearrange. So 7 is going to lead because it is positive. X is going to follow because it's, and 5 already became positive. This is the proper way of answering this. So if you answer, if it was a free response, no. But if you are looking at a multiple choice situation, then either one of these could be a multiple choice. Does that make sense? Then you choose the proper one. You choose the the proper is correct. They're both correct, but this one's not proper. Okay? That's just a name. That -1 means inverse function.
The next one scares me.
Okay? Fractions are our friends.
No, they are not.
All right? Fractions are our friends. Okay? Fractions are our friends. And you need to accept that. We will be using them all year long. All right? So again, just because it says this, does that really matter? No. So we're going to switch our X and our Y. And that gives us X equals 5/9 times Y minus 32. Our goal is to get Y by itself. So fractions, all you are afraid of them for the most part for some strange reason. I don't know why, but this is what you have to deal with first because it's outside of the parentheses. Okay. So it's like the security guard. You can't get in until you get rid of the security guard. Okay. So in order to cancel out a fraction, you multiply. You don't have to. Multiply by the reciprocal. Does anyone remember what a reciprocal is? You flip the fraction. So I multiply by 9/5. And what I do to one side, I have to do to the other. And what this does, it eliminates the numerator and denominator of the fraction, which just makes it into 1. And that's just Casper, the friendly one, so it goes away. So we're left with 9/5 X equals Y minus 32. So what's the last thing to do to get Y by itself? Add 32. And what I do to one side, I do to the other. So Y is now by itself. These are not like terms. So they just become neighbors. So we have 9/5 X plus 32. Now, was that fraction terrible? All you did was flip it. And then it disappeared. Okay, what are your questions about the fraction? In order to cancel out a fraction, when multiplying, it's always multiply by the reciprocal. Okay, because essentially what you're doing is you're multiplying by 9 and dividing by 5, and that's what the reciprocal does. Okay, tomorrow and Wednesday. All right, I think we can do one more. I think we squeeze in this one. All right, guys, we're gonna squeeze in 4, and then we're gonna do the last 2 tomorrow, and then we'll keep it trucking. All right, so 4 is different. This time we're dealing with a quadratic. Okay, if we're looking for the inverse of a quadratic, what did we say the inverse of a quadratic was? A square root. Okay, so keeping that in mind, our inverse is a square root. What that means is that there's going to be some type of restriction. And that's because underneath the square root, what can we not have? No negatives. This has to be greater than or equal to 0, okay? So when we are switching x and y, we end up with x equals 2y squared minus 6. What are the steps that it's going to take for me to get y by itself? I can't do anything until I SAD method. Is there anything I can add or subtract away? I'm going to add 6. So I'm left with x plus 6 equals 2y squared. Now, is there anything I can multiply or divide away? Divide 2. What I do to one side, I do to the other. So this is going to lead to x divided by 2 plus 3 equals y squared. And now what do I need to do to get y by itself? I'm going to take the square root. So when you take the square root, that frees your y. So we have y inverse equals the square root of x divided by 2 plus 3. But what has to happen with this here? X has to be what? That whole thing has to be greater than 0. And if it's not, so we have to establish what our restriction is. So x plus 2 divided by 2 plus 3 has to be greater than or equal to 0. And we will subtract 3. That gives us x divided by 2 is greater than or equal to -3. What's the opposite of dividing by 2? Multiply by 2. And what is -3 times 2? So this is saying that x has to be greater than or equal to. You have to state the restriction in order for it to be a function. It gets a little, we build, okay? All right, so we will resume mañana.